All right, so today we're in section 9.4, rational numbers. What do you think of when you hear the word rational, for something to be rational?
I mean, like, you split it for, like, people, like, rations that you eat.
Okay, somebody else said that last hour, too. Not like rations, like rationing food, but rational, like, oh, that's rational. Josh, what do you think?
Like, when I think of rational, I usually think rational.
Yeah? Or like logically, or it makes sense, right? So for something to be rational, it has a pattern. It makes sense. You guys know the opposite of rational?
Irrational.
Irrational, okay? So whether it's rational or irrational, all numbers are classified as real numbers, okay? So that's all numbers in like the whole universe, okay? It's a real number. But rational numbers can be written as fractions. That's what we're focusing on today. In section 9.5, we'll be learning about irrational numbers. That's not until 9.5, though. Okay, so the rational numbers can be written as fractions. They are terminating or repeating decimals. Do you guys know how to identify a repeating decimal? It's got that bar notation, like 2.3 with the bar over it. Or it might be 2.35 with a bar over two numbers, right? And that tells me that both numbers repeat. Well, what's a terminating decimal? What do you think that is?
It doesn't repeat.
It stops, okay? It could be something like 1.75 or 4.2, okay? But there's a stopping point. There's an end. There's no ... after it. Now, an irrational number, an example of irrational would be something like 3.45273 with no discernible, you can't see a pattern, there's nothing repeating, there's nothing terminating. The dots mean that the number continues. That would be an irrational number. So an example that you could see is something like the square root of 2. Because if you take the square root of 2, that's going to be a non-terminating, non-repeating decimal. All right, those are just two examples. But again, our focus today is not on irrational, okay? It's on the rational numbers. You got that? We'll just pause for a second. Anybody still writing? All right. Okay, so moving on to example 1. In example 1, I want to write these fractions and mixed numbers as decimals. So how do I know that a fraction is a mixed number? What gives it away that it's a mixed number?
Oh, it has a whole number and a fraction.
Exactly. So the whole number goes in what decimal place? No, it goes in the ones place, okay? So the whole number goes in the ones place. And then the fraction part would go in the decimal places. All right, so just to review decimal places, let me just kind of put a decimal number up here. If I said 3.58, the 5 is in what place value? The tens place. The 8 is in the hundreds place. Okay, so when I'm talking about place value, and the 3 is in what place? The ones place. When I talk about place value, that's what I'm talking about, okay? All right, so with that in mind, I'm looking at this fraction, and I look at the denominator, and I ask myself, is this denominator divisible by one of my decimal place values? Meaning, can 5 be divisible by 10? The tenths place?
Yeah.
Okay, so if I can make my denominator one of those place values, the tenths place or the hundredths place, then I can write this as a decimal pretty easy. You said it's divisible by 10? Yeah. How many times? 2. So I can multiply my numerator and denominator by 2, and I get 1 and 8 tenths. Well, now that my denominator is the place value of one of my decimal places, I can write it 1 and 8 tenths. 1.8. So if the denominator is divisible by 10 or 100, it's pretty simple. You just multiply top and bottom, and then you can write it as a decimal. But now we look at this next number, and we look at the denominator. Is that divisible by 100? 33? Or 10? No, neither one. So when it's not divisible by one of them, I know it's going to be a longer decimal, and I have to do long division. The numerator goes inside the long division, and the denominator goes outside the long division. All right, so this is a little bit of a review of long division. Does 33 go into 5?
No, you gotta add 2 zeros.
Okay, 0.
Or 1 0.
Okay. Does 33 go into 50? Yep, once. And so my long division begins. Subtract them and I get 17. Bring down another 0. 170, about how many times do you think? About 5 times. You are correct.
Yeah.
165. Got my 5. My 0. This is my first indicator that I might have a repeating decimal, but I need to keep going to verify. 33 goes into 50 once. 33, and now I know. Now I know. 0, and it's 5. So my answer here would be, yep, 15 hundredths repeating. All right, now I want you to do negative 2 over 9. Okay, I want you to do this last one on your own.
Why did you?
I'm going to walk around and check on you guys.
Number one, why did you multiply?
So 2 divided by 9. Don't let me forget the negative at the end. Almost forgot last hour. Okay, so 2 divided by 9. Okay, 9 doesn't go into 2. Decimal 22. 18. 2. Bring down my 0. All right, so this one's going to be pretty straightforward, isn't it? It's just that 18 and 20 over and over. Once I go out 3 times, I can confirm that that is a repeating decimal. Negative 0.2 repeating. Did you guys remember your negative? I know it's easy to forget that.
I just put a point negative.
Okay, if you don't have the 0 in the ones place, it's not a huge deal, but I would rather you have it. Okay, so just put it in there. A lot of times when you box in just that decimal, it can kind of bleed over that decimal point, and then I think that you forgot it. All right. Okay, in the next example now, we're going the other way. We're writing a repeating decimal as a fraction. And you might think, oh, no problem. You know, that's 0.25, 25 over 100. But it doesn't work that way because I know that that 0.25 repeats over and over again. I actually can't convert it the way that it is right now. I have to find a way to actually get that repeating decimal place to cancel out. And so there's a very specific strategy. All right, the first time I explain this, it's going to seem a little weird. All right, but if you follow along, by the time we get to the end, last hour they were getting it really good. Okay, so just follow along and I'll walk you through it. So my first step is to take the decimal that I'm converting and put it into an equation. X equals 1.25 repeating. I'm going to put it into an equation. Do that. Okay, go ahead and write that in. Now I need to look. How many digits are repeating?
2.
How many digits repeat? There are 2 digits repeating. Does everybody agree? So because 2 digits are repeating, I'm going to multiply both sides by 100. All right, meaning that 2 place values. Multiplying by 100 would move 2 place values. Okay, so 100 times x, I'm going to multiply both sides, 1.25 repeating times 100. And when you do that, guys, when you multiply something by 100, what happens to your decimal point? When you multiply by 100, it moves to the right, however many places. 100, it would move to the right 2 places. We're trying to move that decimal behind those repeating digits. Doesn't mean they go away though. So 100x equals 125, but my repeating decimal is not gone yet, 0.25 repeating. Does everybody see how I got to 125? Okay, so let me explain what I just did. I multiplied by 100 because I had 2 repeating digits. Are you guys following me to that point? Okay, then when I multiplied 1.25 times 100, that moved my decimal to the right 2 places. But this 2525 kept going. So I still have it in my decimal value. All right, I'm going to keep going. All right, my next step is to subtract my original equation. Connor, head up. Minus x equals 1.25 repeating. And now look what happens. 100x minus 1x. What's 100 minus 1? 99. 99x equals, and now my repeating decimals cancel, which is what I needed. 124. And now last step, how would I get x by itself? Divide by 99. And I'm going to change that. Honestly, if you left it an improper fraction as long as it was reduced, I would be okay with that. But your book converts this back to a mixed number. Okay, that's why we're going to do 4 of these. By the time you get to the 4th one, if you guys follow along, I really think you should have it, okay? I know that this is like completely new, and that's okay, but if you stick with me, I really think you'll get this. On the next one, 0.8 repeating. What was my first step? What did I do over here on my step 1 on my first problem? I put it into an equation. So I'm going to do the same thing over here. I'm going to say x equals 0.8 repeating. 0.8 repeating. Now I need to figure out, what would I multiply this equation by? What would I multiply it by?
10.
How did you know 10? Because, hold on, and it doesn't have anything to do with the tens place. How many repeating digits are there? 1. Because there's 1 repeating digit, I'm going to multiply both sides by 10. Okay, so 10 times x equals 0.8 repeating times 10. Okay, so 10x, that's easy. But what's going to happen to my decimal when I multiply it by 10?
It's going to move one way.
It's going to bump my decimal to the right 1 place. But remember, that 0.8 is still repeating. Okay, so while it bumps my decimal to the right and it becomes 8, I still have my 0.8 repeating. Okay, all right, so I multiplied by 10. Now, anybody have any guesses? We've already done 1. What am I going to do next? What's my next step, Micah? Subtract what?
The 10x. 10.
I come back now and I subtract my original equation. Okay? And my whole goal in doing that is to get this repeating decimal. Now it's going to cancel out. Minus 0.8 repeating. Okay, now that my repeating decimal cancels, now I can solve for x. What's 10x minus 1x? 9x. So 9x equals, what's 8 minus 0? 8. And now how do I solve for x?
You just divide it.
Divide by 9. So x equals 8 over 9. We're going to do 2 more. There's a reason we do a bunch of these, okay? Hopefully, maybe it's starting to make a little more sense. Like, do you understand why we multiplied by 10 up in step 2? Do you understand why we multiplied by 10? No. because we had one repeating
Oh, you
digit.
gotta get it past the decimal?
Yes,
Oh, okay.
Okay.
I get it.
we had
Because
one
25,
repeating
you had to
digit.
move it
So
twice.
that's why Josh was asking, what if we had 3 repeating digits? You will
Then you
multiply
move
by
it 100.
1,000,
No, I mean
3.
1,000.
Okay?
It depends on how many
Repeating
numbers.
digits.
I got
Okay?
it now.
All right, let's keep going. Negative 4.5 repeating 0. So funny. Do you think that 0 means anything?
No.
No, a 0 repeats in a decimal place. That means nothing to me. All right, step 1, put it into an equation. X equals negative 4.5 repeating. Step 1, put it into an equation. Negative 4.5. It would have been no big deal had that 5 not been repeating.
Well, on the second one, there's a 0.
I know. The 2.6, I changed it. I want to keep these numbers fairly simple while we're still getting used to the process. So I did change 2.6 to 2.6 repeating. Okay, so we will make that change in a minute. All right, but for now we're focused here. Did you write x equals negative 4.5 repeating?
Yes.
Did you write that? I want you to try to multiply it. You can work together in your groups. Figure out what you're going to multiply this one by and go ahead and do that, okay? So let's try to get to that next step. So work together, put your efforts together and try to figure out how to rewrite this equation. It's okay if you're still getting stuck. It's okay.
Mr. Kennedy, just enter, right? It's mine, right? It's mine, right?
Miss Kinder,
I'm not sure.
did I do this right?
Okay, we'll keep going. I've got the recording going. Okay, guys. So what did you multiply both sides by? 10, because we have one repeating digit. So I get 10x equals, and then I bump that decimal to the right when I multiply by 10, negative 45.5 repeating. Now, anybody remember the next step? What do I do next? Cam? I didn't skip a step. I just kind of multiplied it here. And I multiplied by 10. All right, do you want me to show? All right, I'll go back. Okay, so what I did was I did 10 times x equals negative 4.5 times 10. But when I multiplied this by 10, repeating, it bumps my decimal to the right. Okay, so now what I had written was 10x equals 45.5
I got that. That's what
repeating. Good.
I got. That's what I got.
Now what do you do? What did you say, Mason?
Subtract.
Subtract what?
The original.
Subtract the original equation minus x equals, told you would get it, negative, don't forget that negative, 4.5 repeating, okay?
Wait, what?
And this is how.
I have to subtract the original problem.
But how would you talking about what homework? Explain that.
Did that.
How you get a negative 4.5? I thought it was 45.
No, you have to
subtract
subtract
it from
the
the
original. You got to subtract the original. Okay, so now, guys, just let me get through this, okay? Subtract the repeating decimal. 10x minus x is 9x. Now be careful. What's, oh, sorry, I forgot the negative 45. What's negative 45 minus 4?
Negative 49.
Negative 49. Okay, now divide by 9, both sides, and change back to a mixed number, negative 5 and 4 ninths.
Okay, so you want us to.
So you have to
You lost your
divide after you get the 9x.
Yes, you need to divide. Yeah, change it back to a mixed number. Okay, so I'm gonna turn it over to you for this last one. I'm going to pause the recording just for a little bit. Okay, so we're going to pause here. I'm going to walk around and kind of see where you guys are, see how you're doing with this. And I want you to try to convert 2.6. Now, I did change this problem to make it a little easier. It's not 2.06. We're going to do 2.6 repeating. Try to convert that to a fraction. All right, so we'll pause here for a little bit. Okay, so 2.6 repeating. We have x equals 2.6 repeating. I multiplied by 10. Mason, I'm gonna kind of do some of this mental math if that's okay. 10 times x is 10x. Does everybody see how I got 10x? Because I multiplied by 10. When I multiply 2.6 repeating times 10, I get 26.6 repeating. Everybody see how I got that? Okay. Now, I must subtract my original equation, minus x equals 2.6 repeating. It's real important that you line up your decimals so you can see the repeating cancel and you get 9x equals 24. Okay, how do I get 9x? 10x minus 1x is 9x. Now I divide both sides by 9 and x equals 24 over 9 or 2 and 2/3 because 6/9 reduces. Okay, I'm just kind of running out of room. All right, you guys did a great job. I'm really proud of you. A lot of you guys did really, really well on that. I feel like we, looking at the homework assignment, looking at the numbers, feel like we're in a good place. I know we do have example 3 left. We'll talk about these challenge questions and we'll be done after the challenge questions and we'll do example 3 tomorrow, okay? So, like, just to kind of sum it up, how can you tell if a number is rational or irrational? Just to kind of sum it up, Connor?
It can be written as a fraction.
Connor?
Oh, because if it's rational, it like repeats or it,
Yep.
it like commutes.
All right, so rational numbers can be written as fractions. Irrational can't. All right, so Josh said that part. And just like Connor said, it's terminating or repeating. Terminates or repeats. Okay, so now I want you guys to work together and don't overthink this. Try to come up with any example of a rational number. Okay, any example of a rational number and any example of an irrational number. We kind of gave some at the beginning of the lesson, but you can't use those same ones. Use your own. Okay, come up with an example of a rational number and an irrational number. Anybody have an example? Connor?
For rational?
Yep.
Oh, 4.16 and 1/6 is repeating.
Okay, 4.16 and the 6 repeats. That's great because it's a repeating decimal. Any others? Anybody else have an example of a rational number? How about 10? It's a whole number.
Yeah.
All right, -5. How about the square root of 9? Square root of 9 is 3, which is a whole number. Okay, we'll talk about that in 9.5. All right, what about irrational? I heard somebody say they did irrational. Josh?
77.77
No, because repeating is rational. But what about 77.235441? Dot, 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 dot. All right, there's no pattern to that decimal. It's going on and on. That would be irrational. The square root of 2. The square root of 5. If you take that decimal goes on and on. Square root of 7. Okay. All right, so we're going to end there. We'll do example 3 tomorrow, but that's enough for you guys to get started on your homework. I am going to take off number 23 on your homework. Okay, it's just, more of the same. So we'll take off number 23. I'll send out a text on that one, and that'll be it for today.